Okay, for the concavity, I need to find the second derivative. So we got x to a power, a is a constant, so I take the number, put it out in front, or take the power and put it out in front, lower your power by 1. Then for our second derivative, take our power, put it out in front, so we got 4 times 3a x, and then lower by 1, which gives us 12ax squared. Now to find our critical values, we set that equal to 0, and I want to solve for x. Well, if I divide both sides by 12a, because both of those are numbers, remember a is just a number, then we're going to get x squared equals 0 divided by that gives us 0. Drop our squared, put a plus or minus square root on the other side, and we get x is equal to 0. That's our critical value. So now I want to plug that in and choose test cases. So I want to choose something less than 0, like -1. Choose something greater than 0, like 1. And I want to plug those into my second derivative. So I'm going to plug them in here. So I'm going to have here 12a times -1 squared. -1 squared is 1, times 12 is 12a. Now over here, if I plug in x equals 1, 1 squared is 1, times 12 is 12, so we get 12a. For what values the constant a is the function concave up? Or what one is it concave down? Concave up means we want a positive. Concave down means we want a negative. So if I think about the a here, if I plug in 0, 12 times 0 is 0, well, that's neither positive nor negative. But if I plug in a negative value, which means if a is negative, for example, like a is equal -2. 12 times -2 is -24. That'd be negative, so that'd be concave down. So it's concave down when a is negative, which writing it in this notation would be from -infinity to 0. Now on the other hand, if a is positive, like 5 for example, 12 times 5 would be 60. 60 is positive, so that's concave up. So it's concave up when a is positive, which is from 0 to positive infinity. And that's how you determine those.